Welcome to the Petal Enclosure build video. In this video, we will go through all the steps to building your own Petal rig enclosure. Whether you decide to purchase one of our DIY kits or if you build the whole thing from scratch, this video should guide you through the entire process. Certain steps in this video will not be necessary for those of you that purchase the kit, so to make things easier to navigate, I will put a yellow border around the frame of all those specific steps. This video will also act as a resource for those of you that already have a rig and need to make any repairs or modifications. And for those of you that will be building this from scratch, certain steps like 3D printing and laser cutting the parts are not shown in this video, but all the files to do so along with the full parts list are available on our website, petallighting.com, for free. Let's get started. Step 1. Pre-assembly. Powering up the brain. In this step, we will be taking out the main electrical components like the DigOcta power board and brain board and the 24-volt power supply and wiring them up to make sure everything is operating properly. Keep in mind, when wiring up any electronics, always take proper precautionary steps to avoid electrocution. But this is a fairly simple process, and if you have any experience with wiring up DC power supplies, this should be very familiar to you. To start, you'll want to gather some parts together as well as some tools. You'll need the IEC plug and the pre-made wires for the IEC plug to the power supply, the IEC or AC power cord, the DigOcta brain board, the DigOcta power board, and the 24-volt power supply, as well as wire strippers, regular Phillips, small Phillips, and a small flathead screwdriver. If you're building this from scratch, you'll also need at least 2 different colored 22 gauge wires, but if you purchase the kit from us, these wires will be included. You'll need to make 3 pairs of wires around 10 inches in length. You could probably get away with shorter, but we found this to be a good length to work with. You'll then want to strip all the ends of the wires in preparation to attach one of these circular wire terminals to each of the wires using a crimping tool, while leaving the other end of the wire bare and stripped. Once done, you can put these to the side while we assemble the DigOcta boards. Grab your power supply and your DigOcta boards and set them into position. The boards come with these small brass offsets that will allow you to stack the boards and screw them together. Use the shorter offsets in the corners of the bottom of the power board and the longer offsets underneath the brain board and onto the top of the power board. There are 5 of the longer offsets because the one connecting the middle of each board is used to transfer power from the power board to the brain board. For more details on the DigOcta setup, as well as much more refined assembly instructions, definitely check out the inventor Keendoor's YouTube channel, Intermit Tech, for everything you might need to know about this DigOcta system. The DigOcta power board has 3 positive and 3 negative connection points that will match the 3 positive and 3 negative connection points on the power supply. The power supply also has 3 more connection points to receive power from the AC plug, but we will get to that in a minute. We use the red and black wires to differentiate where red is positive and black is negative. On the power supply side, loosen the screws with your Phillips screwdriver just enough to allow the metal plates to separate enough to slide the stripped end of your wire between the plates. Do this for all 6 wires, making sure black goes to negative and red goes to positive. On the DigOcta side, you will need to lift up these little orange acrylic covers before loosening the screws. Similar to the power supply, but this time unscrew the screws entirely, as we will want to put them back through the hole on the wire terminals that you installed previously. Again, making sure red goes to the positive side and black goes to the negative side. When it's done, it should look something like this. You can see on both the DigOcta board and the power supply that this is labeled clearly, so just make sure you are matching positive to positive and negative to negative. Next, grab the IEC plug, which has the socket that will allow you to plug the rig into the wall, and connect the 3 pre-made wires to it, where red in this case goes to L or load, blue goes to N or neutral, and black goes to ground. Repeat this step on the power supply side by again loosening the screws and inserting the pronged terminals and tightening the screws down. We actually realized after filming this that in order to install this connector onto the rig later on, you will need to undo this connection. So to avoid this, we do recommend installing the IEC connector onto the 3D printed back panel prior to wiring this part up fully. I'll explain this more later on in the video. Now it's time to plug the IEC cord into the IEC socket, and then plug the unit into your wall receptacle, making sure the power switch on the IEC socket is set to the off position. We highly recommend wearing gloves in this stage as we are now connected to mains voltage. You can now turn the switch to the on position and you should see the board power up. The small 7-segment display on the DigOcta board will show you the voltage that is being received by the power supply. And if it isn't already at 24.0 volts exactly, you will want to use your small flathead screwdriver to adjust this tiny knob on the power supply to get that locked in. This adjustment knob is really tiny, so if you don't have a small enough flathead screwdriver, you can use a pocket knife instead. At this point, if everything goes to plan, you should be ready for the next step, mounting the ports and the DigOcta. In this step, we will mount the XLR plugs and the DigOcta assembly onto the aluminum sidewalls, and the IEC power plug and the Ethernet port into the 3D printed back piece. Note, if you buy the kit, your aluminum pieces will come pre-installed with the 3D printed parts like this. But if you want to make your own aluminum and 3D printed parts, just use some small number 4 wood screws to attach the 3D printed parts to the aluminum. Additionally, with the kit comes pre-soldered XLR panel mount connectors as shown here. If you are doing this yourself, you will want to wire up the XLR connectors with 3 different lengths of wire. 4 connectors with 10-inch wires, 2 with 14-inch wires, and 2 with 16-inch wires. We determined that these lengths allow for easy assembly without being too long. Also be sure to solder the correct colored wires to the appropriate pins of the XLR connectors to maintain the standard we use in all of the Petal rigs we build. The white ground wire goes to pin 1, the red power wire goes to pin 2, and the green data wire goes to pin 3. To begin the assembly, simply screw the 4 XLR connectors with the shortest 10-inch wires onto the DigOcta side aluminum panel using the provided 10mm M3 flathead screws. You can differentiate between the 2 side panels by looking at the 3D printed parts attached. The DigOcta side has the smaller 3D printed bracket. Aside from the 3D printed parts attached, the aluminum sides are identical. Again, if you are DIYing this, you can either tap the aluminum panel holes to accept M3 machine screws like we do for the kit, or drill the holes slightly larger and use a nut on the back side of the XLR connector. For the power supply aluminum side panel, mount the 14-inch length wire XLR connectors to the 2 bottom holes and the longest 16-inch wire XLR connectors to the top 2 holes. Next, you can mount the DigOcta board to the aluminum panel by screwing through the designated holes on the aluminum and into the brass standoffs on the DigOcta. Again, using the provided 10mm M3 flathead screws, making sure the DigOcta is oriented so the power supply wires are facing the bottom of the enclosure. Note, for the DIYers, we also countersink the outside of the aluminum panels so that the flathead screws sit flush. If you buy the kit, you will notice these brass M3 threaded inserts on most of the 3D printed parts, like you see on the back piece here. This is one more additional step you'd have to consider if DIYing the rig. The Ethernet port has a faceplate that needs to be removed for installation, but it comes with its own threading, so no threaded inserts are needed for this specific connector. Just make sure the push-release tab is facing towards the back of the rig when installing. The IEC connector is more standard though, so we inserted threaded inserts for easy installation of that connector. Remember in step 1 how I mentioned it would be best to install this IEC connector onto the back panel prior to wiring it up to the power supply for testing the components? Well, this is why. In order to feed the wires of the IEC connector that you wired up in the previous step through the back piece, you will need to temporarily disconnect it by unscrewing the terminals at the power supply. But if you installed the IEC connector onto the back panel originally, then you don't need to do this. Once again, using a couple 10mm M3 screws, fasten the IEC connector to the designated hole on the back panel before moving on to step 3, wiring up the brain. To start this step, position the power supply face up onto the other aluminum side panel, and if you had to remove the IEC connector from the power supply to complete the last step, you can reconnect it now. Next, connect the Ethernet port to the DigOcta using the supplied 16-inch Cat5 cable. Note that the Cat5 cable in this video is shorter than 16 inches, but we've since started shipping kits with a longer cable to make assembly a bit less tight. To begin wiring up the XLR connectors to the DIG Octa, the order doesn't really matter here, but in the video we start by connecting all the white wires to the green screw terminals on the ground side of the board closest to the 7-segment display. You can see the DIG Octa power board actually has 16 terminals per side, but we will only be using 8. For the cable management, Andy here is using some electrical tape to keep like-colored cables together while making sure the XLR wires aren't getting tangled in with the power supply wires or Cat5 cables, but feel free to go as neat with the cable management as you like. Next, connect the red wires to the green screw terminals on the power side of the DIG Octa. Take note, the power side has all these individual fuses, and half of them are 10 amp while the other half are 5 amp. In this case, you can see Andy is staggering the terminals he is connecting to in order to use the 10 amp fuses and none of the 5 amp fuses. This is a good time to mention that the order in which you attach the red and white wires onto the board doesn't really matter. However, the green wires do matter. But before we wire those up, we recommend removing these tiny little orange stickers on top of these super tiny little dip switches. These switches are set by default to 249 ohms, but we want to switch them over to the 33 ohm setting as this provides better compatibility for 3-wire LED setups like we will be using. Since the green wires will transmit the data that controls each of the 8 fixtures in the rig, we need to make sure that the proper XLR ports are going to the proper channel of the DIG Octa brain. Unlike the power board, the brain has these removable Phoenix connectors to make it easier to insert the wires. Now the brainboard does have the channels labeled, but they are laid out as follows. Channels 1 through 8 in this direction. Now you can decide which XLR ports go to which channel, but we opt to make the top left XLR channel 1, then down the line to channel 4 for the left side of the enclosure. And then starting with the top right XLR on channel 5, down to the bottom XLR, which will be channel 8. Once you have the green data wires fastened to the Phoenix connectors in the right spot, you can simply plug them back into the brainboard. If it was a bit difficult to see exactly where each wire is going, we have a neat diagram in the PDF manual that you can reference. In fact, most of the steps in this video can be directly referenced in the manual and vice versa. Finally, if you haven't already done this, reconnect the antenna cable to the tiny little plug on the brainboard. With the brainboard all wired up, we can now move on to the final step of the build, assembling the enclosure. Begin this step by attaching the rubber feet to the bottom panel using the 4 1024 screws included in the kit. Next, carefully lift the side panels into a vertical position, sandwiching the 3D printed back panel between them, making sure not to get any wires caught. Using 3 10mm M3 screws, you can fasten one side panel to the back panel through the designated holes in the aluminum and into the threaded inserts inside the back panel. You can now do the same with the other side panel, but hold off on screwing in the bottommost screw as we will need some wiggle room to allow the bottom panel to slide in between the side panels. Now you can place the bottom aluminum panel between the side panels, making sure the 3D printed bracket is facing towards the front of the enclosure, and screwing in the one back screw first. The cables inside can make it a bit difficult to get the back panel to sit in right, so adding this first screw will hold it in place and allow you to confirm there aren't any cables getting in the way before screwing in the front end of the bottom panel. Unlike the rest of the rig, the 2 front screws for the bottom panel are longer 20mm M3 screws, as the threaded insert you will be screwing into is on the sidewall trim pieces, and the trim on the bottom has larger holes to allow the screws to pass through into the threaded inserts. You can now screw in the bottom screw of the one side panel that we left out earlier. Next, we will install the handle. And I'm going to switch scenes here because I wanted to refilm this part as the design has changed a little bit since we filmed this tutorial. And I'm going to use this wooden enclosure prototype I had with one of the walls removed so you can really see what's going on here. The handle assembly consists of these parts: the handle, 2 3/8 inch coupling nuts, 2 3/8 inch nuts, 2 3/8 inch bolts, the 3D printed power supply bottom support, the 3D printed power supply top support, and the acrylic top piece for the enclosure, which needs to be installed as part of the handle assembly. This is what the assembly will look like once completed, but there are a few detailed steps involved to make sure everything is sitting straight. Start by inserting the handle through the acrylic top piece. Be careful not to let the threads grind too hard against the acrylic holes during this step. Next, thread on the 2 regular nuts on either side of the handle up a few inches, followed by the top power supply support. Make sure the vertical wall of the support is facing the power supply. Now take the bottom power supply support, which we will be using as a temporary spacer, and insert one of the 2 bolts through it before threading the coupler nut onto the bolt completely. Next, thread the coupler nut onto the handle until it can't turn any further. This will dictate the right distance the coupler nut needs to be threaded onto the handle. Using the regular nut on the same leg of the handle, thread it down towards the coupler nut, tightly sandwiching the top support between the coupler nut and the regular nut, which will help lock the coupler nut in place. Now carefully remove the bolt from the coupler nut, making sure to keep the coupler nut from rotating on the handle. Repeat this step with the second coupler nut on the other leg of the handle. We do all this to make sure there is an appropriate amount of threading left over inside the coupler nut to take the entire bolt once fully assembled, while also making sure both coupler nuts are threaded onto the handle the exact same amount. This will ensure your handle will be installed as straight as possible. Now that the coupler nuts are correctly installed, you can now take your bottom support and line it up with the holes in the bottom aluminum plate of the enclosure, making sure the little tab on the support is sitting on top of the power supply like this. Take one of the bolts and feed it through the aluminum bottom plate and the bottom power supply support before lining the handle up and carefully tightening the bolt. Repeat this step with the second bolt. You should be able to tighten the bolts by hand all the way so you can finish it off with a small turn of a wrench to tighten the whole assembly down. With the handle securely installed, we can install the acrylic vent. Remove the protective cap on the antenna wire if you haven't done so already, and unthread the little brass washers and nut and put them aside. Feed the antenna into the acrylic, making sure the antenna hole is facing the right side of the rig, and bolt it on with the little brass washers and nut. You can now secure the vent to the enclosure using 6 of the 10mm M3 panhead screws. Note, there are 4 extra holes around the vent, which we've added to the design to accept an 80mm computer fan if you like. Finally, secure the top acrylic piece to the enclosure using 8 more of the 10mm M3 panhead screws and screw the antenna onto the antenna wire, and with that, your new Petal enclosure is complete. So I hope this tutorial will be helpful for those of you looking to jump into the Petal ecosystem. As I mentioned previously, you can use this video alongside our PDF manual for additional clarity. Now I'd like to thank my partner Andy for performing the build in this video, and a huge shout out to Javi from Digital Paradise Media for letting us shoot this video in his studio. Go check out his socials at Digital Paradise Media, or check out the link in the description for his YouTube channel. And finally, thanks so much to all of you for your continued support, and we look forward to many more updates and videos this year. So stay tuned. Bye for now.